Hi everybody, welcome to your second to last credit recovery video. So today I'm going to discuss how to convert from radian measure to degree measure and degree to radian. But first let's discuss something really important. What is radian measure? So we just said we're going to convert from radians to degrees and degrees to radian. So you know what degrees are. If I say an angle is 90 degrees, you know you have a right angle. It's talking about how open an angle is. So degree measures the openness. Radian is the same thing. It's just a different unit. Radian also is just like degrees. It measures the openness of an angle. Now, the only difference about radian measure is that it deals with different types of numbers, and we'll discuss those numbers. We'll talk about how to convert. But it's like the same idea as if you wanted to measure your desk. You could measure your desk in inches, or you could measure your desk in feet. Both inches and feet measure length. One is a smaller unit, one is a larger unit, but both are measures of length. And you can convert from inches to feet and feet to inches. So that's what today's lesson is about. We're thinking about converting from degree to radian and radian to degree. So let's see where radian measure comes from. So I want you to focus on the circle for a second. And I want you to think back to a construction of an inscribed hexagon. So if you remember, some of you may not, when you want to construct an inscribed hexagon, you first had to measure the radius. Then when you had the length of the radius, you had to go around the circle and make yourself an arc with the length of the radius. Then from this point, you're going to do it again. And then from that new point, you're going to do it again. And then you kept doing it. I'm just approximating here, so you have to excuse me. I think this needs to be moved a little bit. 5, and somewhere here. So it's a little off, but that's because I'm kind of freehanding it here. But basically what I want you to notice is that this is the construction of the hexagon. Now some of you in class, if you remember, you would try and do the last one and you would end up getting a little short from fitting the circle. Now that was supposed to happen because the idea is here that you don't have exactly 6 parts of the circle. Now this is how you would usually finish the construction. I mean, obviously you would make straight lines. So this is how you would have the construction of the hexagon. It would look something like this. So we're using that idea to help us here. Again, obviously mine is not drawn to scale, so you have to excuse me. So let's think about this. If I had half the circle, I'm going to cut the circle in half, pass right through the middle there. And I drew it by hand, but I somewhat tried to keep it accurate. How many radii fit around half of the circle? You're going to count and say this is 1. Then this one here was 2. This is 3. And this was a bit more. So 3 and a bit more. Yes, I call that little section a bit. So 3 and a bit more fit halfway around the circle. Now if I want to relate this to a radian measure, I can discuss the angle formed where this first radius stops. So this angle right here is 1 radian because it's 1 radius worth of openness. If I were to do another angle here, so if I were to discuss this whole entire angle, that would be 2 radians because it's worth 2 radii of the circle. If I were to go here to this point and discuss this angle, this whole thing from start to finish, right? So from this, remember we started here. So from start to finish, that would be worth 3 radians of openness. So that's where radian measure comes from. Now, one thing I really want you to notice is if half of a circle, well, how many degrees are in half of a circle? We should know this right off the top of our heads. We know half a circle is 180 degrees. So we know half a circle is 3 and a bit more, is equal to 3 and a bit more radian. So the question is, what special number in math is 3 and a bit more? So I'll give you a hint. 3 point, now some of you are already saying 1/4. What number, what special irrational number is that? Some of you are going to say pi. And now pi is correct. And this right here is your key conversion from degrees to radian. There are pi radians in 180 degrees. So you can remember this conversion right here. If I'm going to set up a proportion, actually we'll do that on the next page. So you need to remember this conversion right here. 180 equals pi radians. So if 1 pi is half of the circle, how many pi's is the full circle? Here's pi radians, and then here's another pi radians. So a full circle is 2 pi radians. And so you'll see that a little bit in this picture, these pictures right here. Now something I want you guys to note, regardless of how big or small the circle is, the amount of radians will always be pi in 180 and 2 pi in total. Because as the circle gets bigger, the radius will always get bigger. As the circle gets smaller, the radius is smaller. So the amount of radians around the circle is the same. Just like no matter what circle you have, the amount of degrees is always 360. So looking here, here's an example of 1 radian, 2 radians, 3 radians, pi radians, 4 radians, 5 radians. Notice it's darkening in the angle. 6 radians, and then the whole circle is 2 pi radians. So if I want to convert from degree to radian or radian to degree, some of you know how to set up your unit conversions using fractions equal to 1, but I'm going to focus on a proportion here. In this proportion, I'm going to remind myself, we just wrote up there that 180 degrees equals pi radians. So that's what we're going to use to convert, just like I would convert 12 inches in 1 foot. So when I set up a proportion, I have to say pi to 180. Okay, so that means I'm going radians on top and degrees on bottom. This right here is going to help you, convert. Pi over 180 equals radian over degree. So if you know the radian, you'll put in the radian. If you know the degree, you'll put in the degree. So I'm going to do 2 examples with you, and then I'm going to let you practice a little bit on your own. So it says here, express in radian measure an angle of 75 degrees. Well, first thing I'm going to do is I'm going to write this right here. Well, I'm going to cheat and copy it over, but you guys can write it down. So pi over 180 equals radian over degree. So here I'm going to write pi. This does not change. Pi over 180 will always stay that way. Equals. I know I have 75 degrees, so I'm going to put it in the degree part. So 75, and then I don't know the radian, so I'm going to put x. So what do we do in a proportion? We cross multiply. So here to finish solving, I'm going to cross multiply. I get 180 x equals 75 pi. Now, I don't want to multiply 75 and pi because it'll give me an irrational number since pi is irrational. So I'm going to keep it like this. To solve for x, I have to divide by 180. So I get x equals, now, I can leave it as 75 pi over 180. But I also know that my calculator can simplify the 75 over 180. So I'm going to put 75 over 180 without the pi just to see what I get. And I got 5 over 12. So this is really 5 pi over 12 radians. Now, if they asked me to the nearest tenth, how many radians is that? I would do 5 times pi divided by 12, and I'm going to get that it's about, so I'm going to give the approximately 1.3 radians. So now I'm going to teach you how to ask yourself if this seems like a reasonable answer. Well, let me go back up here. If I know that I have in total, in the full circle, I'm going to choose a different color here. So in the full circle, I have 360 degrees. That's approximately how many radians? You're going to say 6 and a bit more. So let's just say about 6 and a bit more. So that means each radian should be how many degrees? So I'm going to say, hey, 360 divided by 6, that means 1 radian is approximately 60 degrees, because 360 divided by 6 is 60. Now I could have done 360 divided by the 2 pi radians, and I really would have gotten about, I think, 57. Let me just double check. Yeah, about 57.2. So that's close enough to 60. So really, this is approximately. So that really you can ask yourself, hey, is this a correct answer? Let's see. So if we know that 1 radian is about 60 degrees, 75 is larger than 60, right? So it's a little bit more than 1 radian then. Is that what we got? Yeah, we got a little bit more than 1 radian. So that's how you could check if you have a reasonable answer. So let's try and go from degree to radian. This is the last example I'm going to do with you. So now here they give me pi over 4 radians. So I need to make sure pi over 4 goes in the numerator there. So pi over 180 equals pi over 4 over x. Yes, we have a fraction within a fraction, but it's very important that you do that correctly. Then I have to cross multiply. So I get pi times x equals 180 times pi over 4. Now there's a nice little thing here that you need to recognize. If I have pi on both sides, when I divide them out, it's gone, and this becomes a 1. So now I have x equals 180 times 1/4, which is, so 180 divided by 1/4 is 45. So we are going to say that this is 45 degrees. That's your final answer. Now, how am I going to check if that's correct? I go back up here and I say, well, this was approximately how much? Pi over 4 is approximately 0.78 radians. So what that means, it's less than 1 whole. So less than 60 degrees, I did get that answer. I got 45 degrees. So it kind of makes sense. That's really how you're going to check your answer here. And that's how you convert from radian to degree and degree to radian. So I have some practice problems here for you to try. There are 10 questions. Convert from degree to radian and radian to degree. So you may want to pause the video here. Don't forget to keep writing your proportion to solve. So there you have it. There are all the answers. I made sure to keep everything color coordinated and consistent. So I'm going to slowly scroll through the answers so you could check all of your work. I want you to recognize that, again, I'm only putting in the pieces that I know, and I consistently keep it as pi over 180 equals radian over degree. Now remember, the question did not ask me to round, so I left it in simplest form because that's just a good habit. You don't have to, but technically it's really best that you do. Also remember that if I have pi on both sides of an equation, I can divide it out and it reduces, it's away, it's gone, it reduces down to 1. So those are the answers. Radian measure really truly helps us finding the length of an arc. So really, this is why it's important to know radian. It's important to know other units of measure. If you have any questions, feel free to reach out to me. Have a great day, everybody.